So in atomic structure, I will obviously tell you about exam point of view, like how the questions are going to be and what they're going to be about. So starting with that, atomic structure, the examiner basically tests you on three main things. Okay, the first one is subatomic particles. Oh God. So subatomic particles. That's the first thing that they test you on in this chapter. So by that, what I mean is that they might give you any ion and they might ask you that how many particles are there, and not just ions. They can give you atoms, they can give you other things. So for example, let me open the periodic table. Okay, so here we have a simple example, like if the examiner said silicon 4 plus and the numbers are 14 and 29. All right, so that is given to us, and what we have to do here is we have to figure out a way for us to know the protons, the neutrons, the electrons, the mass number, the proton number, and the configuration. These 6 things, if you know, then you're good to go. All right, you will be getting a periodic table in the exam, in the test, so don't worry about that. So these 6 things are the ones that we need to know if we are able to get this subatomic particle part correct for this. So how do you do it? The idea is that the smaller number here, that is the proton number. Okay, so judging by that, we can clearly see that this is 14 and this is also 14. Why? Because proton number and the number of protons is exactly the same. Like that's the name of, that's the idea of what this is, right? So that's the first thing. Second, how do you find neutrons? Now remember that this number, the bigger number on the left side, is always the sum of protons and neutrons. And that is the first definition that you need to know, that what is atomic mass. Okay, so that is one definition that you need to know about. Similarly, you need to know about proton number, another important definition. NO dot basically means number. I don't want to write the whole thing. Now, atomic number mass is also called nucleon number. Okay, that's another term that we use. But regardless, what it basically means is it's the sum of protons and neutrons. Okay, now what you have to remember is that you cannot write in abbreviations in your exam. So you have to write the full word, protons and neutrons. You can't just write P or N or something like that. Okay, all right, so we can clearly see that that is 29 here. And what is proton number? It's the number of protons. Okay, so it's it can't get any easier than that, the definition. Okay, so we have the proton number, the nucleon number. Those are the 2 definitions for this. And number of neutrons is always this minus this. So you take these 2 numbers on the left, you subtract 1 from another. So 29 minus 14, that is 15. 15. Yeah. So that is our definition for this. The number of neutrons you can figure out from this atomic mass equation. So if you think about it, in this chapter, there are 2 definitions, and those definitions can also be considered in the formula. So the first formula is atomic mass is protons plus neutrons. That's the first formula. So you can use this formula in case you're confused and you can get your answer. Similarly, the second definition, charge is protons minus electrons. Or if you rearrange it, you can bring this electron to this side and charge to this side. Sorry. So we can say that electrons is proton minus charge. And you can also use this to figure out how many electrons you have, what charge you have, all that. So let's see, over here, I have charges 4 plus and protons are 14. So 14 minus 4. Now, okay, so that is 14 minus 4, 10. And there you go. 10 is the answer for this. Yes, Hania, we do have MCQs in the exam. I think there's 10 MCQs in yours tomorrow. Okay, so we have 10 electrons now. I used this equation to figure that out. Now that I know that, the configuration will simply be, in the first shell, you can have up to 2. That does not mean that you only have 2. You have up to 2. The moment you get 2, you move to the next one. In the next one, the moment you get 8, you move to the next one. In that one, you get to 8, you move to the next one. That is what you need to know as far as your exams is concerned. Of course, I taught you about the 18-1 or the 2n square and all that. But remember that that was for understanding. In O levels, we also have to consider the exam point of view. So in the exam, they never talk about 18. In IGCSE, they do, but I don't think you guys are having IGCSE right now. So 2 in the first one. Now move on. We have 10 in total, 2 gone. So you have 8 left, and 8 can easily fit in the second. The 2, 8 is your next configuration. Now this one where the last shell has 8 electrons, or it's complete, or it is stable, we call this noble gas configuration. Okay, so that noble gas configuration is the idea that is behind it, that every atom wants to get that. So that's the first question that examiner asks you. It's about knowing the subatomic particles and figuring out the configuration from there. I'm going to give you an example, and I want you to solve it, everybody. Okay, so I'm going to give you, let's say, in the periodic table, I will pick, okay, so I'm going to pick calcium. So this is calcium plus 2, and this is 20 and 42. So go on, everybody, for yourself, calculate the proton, the neutron, electrons, the atomic mass, the atomic number, and the configuration. Go on, calculate it. Yes, Azan, I know. Okay, so this one you can easily solve. Protons are the smaller number here, so that's 20. Mass is the bigger number here, so that's 42. Neutrons are these two numbers subtracted, so 42 minus 20, that's 22. Very good, Ayat. And protons are 20, there you go. Electrons are charge is 2 plus, so proton minus charge, that is what electrons are. So 20 minus 2, 18. Okay, now it could be a negative number as well. For example, if this was minus 2, I would say 20 minus 2, and that will make it 22. But over here I have plus 2, so 20 minus 2. So 18, now the configuration is 2 in the first one, 8 in the second one, 8 in the third one, and that's a total of 18. So there you go, we're done with this. So that's the idea of subatomic particles, and the examiner tests you on that. The second question that they ask us about is about the finding particles that are similar to this. So for example, take out the periodic table, and let's say examiner asks you that find one negative ion. So let's say the examiner is going to ask you that find a negative ion with same configuration as this Ca2 plus. So how do we do that? We go to the periodic table. So you all should have your periodic table with you right now. So in the periodic table, notice that calcium 2 plus is just like having argon's electrons. So it's not argon nucleus, but the electrons are like argon. Okay. So pick anything that will be like argon. So for example, if you look at argon, so the idea goes like this. So you have argon, you have calcium here, you have potassium here, you have chlorine, you have sulfur, you have phosphorus, you have silicon, all that. Now remember, if calcium wants to have same electrons as argon, it has to move 1 and then 2 steps back. Okay, so 2 steps back, that is getting to argon. So that's why it's 2 plus. 2 steps back. Back means losing electrons, so it's positive. So if you lose electrons, you're more positive. If you gain, you're more negative. Okay, so because moving 2 steps back, it's 2 plus. Potassium, if it wanted to do the same thing, it will move 1 step back. Okay, so potassium would be +1, and potassium will also have the same electrons as argon. Now let's look at chlorine. Chlorine, if it wants to become like argon, it has to get one extra electron. It has to move one step forward. Forward is negative charge. Okay, forward is negative charge. You need electrons to do that. So that's why you'll get Cl -1, because Cl has to get one electron to be like argon. Similarly, sulfur, if it wants to get like argon, it has to move 2 steps. That means it needs 2 more electrons. So it is going to be sulfur with 2 negative. You can write it as -2, or you can write it as 2 minus. Both of them are correct. Now let's try for phosphorus. 1, 2, 3. So can anybody guess what that would be? So Hania's question is that, yes, Zoha, you're absolutely right. I mean, you as well. Good work. So Hania's question is that I still don't get how are electrons 18. So you have to remember that electrons are protons minus charge. So 20 is the protons, 2 is the charge, 20 minus 2 is 18. There you go. Okay. Manal, Ramin, Alicia, very good. You're all correct. So yeah, that's what we will get here. Similarly, you can do it for silicon. Now, in O levels, we try not to do silicon because it's in group 4. It can gain electron, it can lose electron, all of that. But if it did gain electron, it will be 1, 2, 3, 4. So 4 negative. If it gained electron, if it lost, it will be 4 plus. But that's for another day. We'll leave it out for that. No, sulfur won't be -4, Zoha, because sulfur has to go 1 and 2 steps forward. So that is why. Yes, Fajr, you're right. Okay. All right. So that's the next thing. Similarly, the second kind of question that you get in this chapter is about the diagram. Okay. So you have to draw the this diagram, the circle, the atom, if you want to draw it. So let's pick an atom from the periodic table. Let's say we have aluminum. Okay, so we have aluminum, and aluminum is what we want to draw. Now, here's the thing. I know in grade 8, you're used to drawing the nucleus, and you're used to drawing the protons and the electrons and all that, but I would strongly suggest, in fact, I'll tell you to make sure not to draw the nucleus anymore, not to draw the protons and neutrons anymore. Okay, so just put Al in the middle, and that's it. You're done as far as the nucleus goes. That's all we're going to put. Okay, now why can't we draw the nucleus? One reason that I can think of is that if I did draw the nucleus, somebody can mistake it to be the first shell. We don't want to do that. So that's why I would argue that we should just avoid it. Okay. Okay, so now aluminum has 13 and 27. I'm getting that information from the periodic table. So aluminum has 13 protons, and you can see that there's no charge. If there's no charge, it has 13 electrons, because remember, electrons are protons minus charge. So 13 minus 0 is 13, and that's why it's going to be 13. Okay, so I have 13 electrons. First one will get 2. Second one will get 8. And the third one, these are 10, so 3. So third one will get 3. Okay, so 2, 8, and 3. That's how it goes. So we'll draw 3 shells. Now, remember, you don't need to draw them with a compass. Okay, you don't need to like draw a very accurate, very neat diagram. As long as it's understandable, as long as it's legible, it's perfectly fine. Don't spend too much time on trying to like make a very neat diagram. It's not required. Okay, so aluminum has 2, 8, 3. I'll just put 2 circles here, 8 here, and 3 here. Now, a couple of things that I want you to notice. First of all, notice that electrons, I put them in pairs. Now, there are reasons for this that we don't study in O levels, but it's a good habit. If you're planning to keep electrons in like chemistry in A levels, this might help. It's a good habit to think of electrons as in pairs. Okay, so I would suggest that you draw them in pairs. It's also easier to check. It's also easier to count. So you're not that prone to making a mistake that way. Second, there are 3 symbols that are allowed in your exams. You can use cross, you can use a circle, or you can use a circle that's filled up. Okay. No other symbol should be used. And try to make it a very clear symbol. Some students do this. Sorry. Some students would just draw a very small dot like that. Now, try not to do that. If you feel like it's taking too much of your time, just draw a bigger circle or a bigger cross. That way, it will be easier for the examiner to check. And of course, your question will be correct. Now, this is when you're drawing atom. The other diagram that they can ask you is about the ion. So let's say they gave us the same idea, this thing, but this time they want us to draw this. Now to do that, again, you need to figure out how many electrons you have. You have aluminum in the middle. Notice I do not draw or write the charge. It's just aluminum in the middle. And electrons are going to be 13 minus 3, proton minus charge. So that's 10. Now that's going to be 2 in the first one, 8 in the second one. So I'll draw 2 circles, not 3 this time, because it has lost 3 electrons. I put 2 in the first shell, 8 in the second shell. Notice that if you're using a circle, use circle throughout. If you're using a cross, cross throughout. Yeah, I agree with that. Okay, now here's the thing. How do I know that this thing is an atom and that thing is an ion? Like, how do you differentiate between them? There's a way to do that. You do square brackets, okay? So square brackets with a charge here. So square brackets for ions, okay? So if you're getting ions, you do square brackets. All right, so just remember that. So considering this, I'm going to give you a question. Try to solve that just to know whether you will fully understand this or not. So I'm going to ask you to draw, let's say nitrogen, and I want you to draw nitrogen 3 negative as well. So this is 714, 714, but draw both of these. Go on. If you have any questions, feel free to raise your hands.
Sir, you said that electrons only exist in duplets, and that's how I learned it. However, I was attempting past paper questions today, and that wasn't always the case. We had separated them and put them in like single, I don't know.
Yeah. So
but
for
it
example,
wasn't
you can
present
see
in
over here. You're right. For example, you can see this one over here, right? So here an electron is just by itself. And while it can exist like that, it's not very stable. So it will try to bond, or it will be gained or lost or shared, or something will happen to this before this aluminum atom is stable.
Sir, that's not what I meant. Even if it was 4, it would have 2 in that shell. However, it would still choose not to be present together. Why is that? Is it because it's still unstable?
I don't get it. If it has 4 in that shell, you can draw 2 pairs of 4, or you can draw one, like all of them separated, and they will both be correct. As far as O levels is concerned, there's nothing wrong with it.
That's what
I'm just saying. Yeah, I'm just saying that it's a good habit to put them in pairs. It's easier to check when you're rechecking your exam. It's easier to count them. And of course, it's a good habit for senior classes. Yes, Ahmed.
Do you remember when you made us do the melting and boiling point chart thing? I understand the melting point part, but I'm really confused about the boiling point. I think I've forgotten.
It's okay. I'll check about that once we get to that. Don't worry. I will adjust that. All right. So if you have done this correctly, you might have seen that you have 7 electrons in this. So 2 and 5. Similarly, you have 7 minus 3. So that is 7 minus 3. That's 10 electrons in this one. So that must be 2 and 8. So now you draw this. So nitrogen goes like this. Okay. So I'm using process here. No particular reason. I just wanted to use a different symbol. So that's that. And similarly, nitrogen, this time I have 2 shells again, but this time there are 8 in here. So I'm using this. And because it has a charge, I will use square brackets, -3 or 3 negative. It's up to you how you want to do it. All right. So the charge in the periodic table is always 0 because periodic table is of the atoms. But the ion can have different charges, and those charges will be given to you in the exam, or there will be a way for you to figure it out. Don't worry. So there will always be either the charge will be given or they'll ask you to do that. Okay. So that's that. Talking about subatomic particles, there's a definition that you need to know about, and that definition is isotopes. The isotopes are atoms of same element. Now, this same idea that they're from the same element, you can also write atoms with same proton numbers. Okay, you can say that. With different mass. If you don't want to say mass, you can say nucleon number. If you don't want to say that, you can say number of neutrons. Okay. So there's 2 ideas here. Number 1 is that they have to have same element or they have to have the same proton number, one of the 2. And the second one is they have different mass or different nucleon number or different number of neutrons. Okay, so these are the 2 main ideas that isotopes, the definition of isotopes must have, and you should be able to tell that from whatever the definition is that you write. Similarly, another fact that you need to know about this is that how periodic table is related to atomic structure. So the period number in the periodic table equals the number of shells. So for example, because nitrogen here has 1 and 2 shells, it is in the second period, and you can confirm that from the periodic table. Similarly, aluminum over here, I'm talking about the atom, not the ion. Aluminum over here has 1, 2, and 3 shells. So that means aluminum must be in the third period, and that is true. And same is the case for any other atom that you think of. Okay, so that's how they are. Similarly, the group number, which is the column, the top to bottom thing, that is equal to number of valence shell. Okay, so valence shell is the outer shell. Okay, so that's going to be the same. Okay, so that's the second kind of question that you get in this chapter. The third kind of question that you get in this chapter, and that's the last kind, is finding the AR. Okay, now what is AR? AR is, you need to know the definition. It is the average mass of all isotopes compared with 1/12 of carbon 12. Now, this 1/12 of carbon 12 is basically the unit. That's what it is. Because 1/12 times 12 is 1, and 1 is a unit. So we just need to mention this. There's a scientific reason why we need that, and there's a mathematical reason why we need that, but we don't need to get into that. We study that in A-levels. But for now, just the definition is good enough. Similarly, in your book, they have mentioned that instead of saying all isotopes, they've mentioned all naturally occurring isotopes. Of course, that is the complete definition. But if you don't write all naturally occurring, you just say all isotopes, in O-levels, that's acceptable. Okay, so this is what you have to say. Similarly, in your book, they mention it's not just the average mass, it's weighted average. That's also right. Of course, that's a complete definition. But if you just write this part in O-levels, that will be acceptable because we're trying to simplify things in O-levels. Okay, so this is like in 2.3 of your syllabus. So now, how do you find AR? That calculation is important. So what the examiner does is they give you a couple of what do you call isotopes. So for example, here's a question. Let's say, and I'm just making it up, there's no like reason for that. In fact, I can just find it online. So let's say boron. Okay, so boron Wait a minute. How many isotopes does boron have? That's like so many of them. Okay, so let's say nitrogen. Let's say nitrogen. So nitrogen has two isotopes, nitrogen 14 and nitrogen 15. Okay, and the examiner says that nitrogen 14 is present how many times? Nitrogen 14 is, yeah. So here's the question. The nitrogen 14 is present 99.6% of the time, and nitrogen 14 is present 0.4% of the time. So this part is called abundance. Basically, it's the percentage of that thing in the world. And these are the different isotopes. Now, how do you find the AR from this information? So it's pretty straightforward. AR is you multiply the average, like you have to take the average, right? And this one is 14 times 99.6 for this one. And for the other one, 15 times 0.4. I know some of the branches are not doing this, and that's perfectly fine. Your administration will take care of it. Don't worry. But later on in December, you're of course to use this. So don't worry. All right. So we just multiplied the number, the mass number or the nucleon number with the percentage. And you just add it all up. And because it's percentage, divide by 100. You can choose like do it individually. You can do like this. 99.6% is 99.6 over 100. 0.4% is 0.4 over 100. You will get the same answer. You can divide the whole thing by 100, or you can divide them individually and then do it. All of that is correct. Okay. So you will be provided with these numbers and the percentages. Okay. That part you will know. Again, this is a simplified version for O levels. Later on, you will encounter questions in grade 10 or grade 11 where you might be asked to find the percentage from the data given. And that's also, when the time comes, we'll review that. All right, so we just do it. We put it in a calculator. It spits out the number. That's the relative atomic mass. Okay, so I'm going to give you a question. Take a minute. Okay, so let's say we have, and again, I'm just making it up. We have copper 63 and we have copper 65. This one is present, let's say 60% of the time, and this one is present 40% of the time. Again, I'm just making it up. It's not actually like that. So go on, try to figure out the percentage or the AR for this thing. All right, so what we need to do is multiply 63 by 60 and 65 by 40, divide it all by 100 and add it. So that will give me 68, I guess. Okay. Some isotopes are, and this is the last main idea here, radioactivity. So some isotopes are radioactive. That means they are unstable nuclei or unstable nucleus breaks down, releasing energy. And of course, it does release some other things as well. But for now, we just need to know that it releases energy in the process, which means it might be glowing, which means it might be hot, things like that. Okay. So that's what radioactivity means. It releases energy and it's unstable nucleus. Okay. So yeah, so that's all that you need to know for this chapter. Yes, Rami, what's your question?
Sir, I wanted to ask, could you explain the method, like how you find the relative mass again?
Yeah, sure, of course. What you do is you take the percentage, and at this point, percentage will be given to you. You multiply it by the masses of each item. So if there are 5 isotopes, you multiply each one of them. So for example, if I had what, let's pick, let me take another example. So let's say I had, again, I'm just making it all up. It's not how things naturally are. So let's say there's fluorine 18, there's fluorine 19, there's fluorine 20, there's fluorine 22. Okay, so let's say this is present. And again, I'm making it up. This is 20%, this is 15%, this is 35%. And what would that make it? 60 and 8. So this is 20%. I think that's a total of 100, isn't it? No, it's not. So let's say this is 30%, because it has to be 100%. All right, so we have 4 isotopes, and we want to know how to find their average. So again, it's really simple. What you do is you multiply the number, the mass, with the percentage. So you do it for each one of them. So 18 times 20, 19 times 15, 20 times 35, and 22 times 30. Now you're done that. Just add it all up and divide by 100, because the total. And there you go. Once you do that, you have the average, and this is AR. Again, there will be questions in O levels where you might be given the AR and you have to find percentage, but that part comes later. Now is not the time for that. Stable and unstable isotopes, you will not be asked about that. You just need to know that there are some nucleuses or nuclei that are not stable for reasons that, in fact, humans don't fully understand. But there are a few good theories or good explanations of why they're unstable, not in our syllabus. Okay, so just know that some nucleuses, for some reasons that we don't need to concern ourselves, they're unstable, and because of that, they release energy and other things. Yes, foreign.
Sir, I couldn't understand when you were finding the negative ion with the same configuration as Ca plus 2.
Okay, so I'll go back to that. Yeah, so over here. So what I was doing is I was looking at the periodic table, and in the periodic table, this is how the things are. There's calcium, there's potassium, there's argon, chlorine, sulfur, phosphorus, all of that. Let me take another example. So basically, the idea is you move forward in the periodic table, you get a negative charge. You move backwards in the periodic table, you get a positive charge. Okay, that's the idea. And however many steps you do, that's how the charges are going to be. So let's say we talk about the second and the third period. So over there, I have what? Carbon, nitrogen, oxygen, fluorine, neon, and sodium, magnesium. I think that's good enough. Aluminum over here, things like that. Now, this is just a part of the periodic. Let's say examiner says, they give you oxide. They're like, find 4 ions that have the same electrons as oxide, or find 4 ions that have the same configuration as oxide. So how do you do that? First, identify what's the configuration of oxide. So oxide has 2 negative. So start at oxygen, move 2 steps forward, you get to neon. So that means oxide is the same as neon as far as electrons are concerned. Okay, so now you're looking for a way to get to neon. That's it. You have to just, it's like a game. You have to get to neon somehow. So let's say I'm at magnesium. To get to neon, I have to move 1, then 2 steps back. So I'll say, because I'm moving 2 steps back, magnesium 2 plus. Because if you move back, you get a positive charge. Let's try it for sodium. So for sodium, I have to go 1 step back. So that is sodium. Because I'm moving back, that's plus. Because I'm moving 1 step, just 1 plus. Let's say I'm at aluminum and I want to get to neon. So 1, 2, 3. Okay, so 3. So aluminum 3 plus. Let's say I'm at fluorine and I want to get to neon. So fluorine, I have to move 1 step, so just 1, and move forward. Like forward is negative charge, backward is positive charge. So forward is -1. Let's say I'm at nitrogen. So 1, 2, 3. I have to get to neon. So that is nitrogen 3 minus, or you can write -3. Okay, so that's how this goes. Okay, Fajr, what's your question?
Sir, I sent you an MCQ in your chat. Can you answer that?
Okay, I'll see. Abrish, the questions that you get about radioactivity are just that. I remember there was this MCQ in the exam that there was some scientists who saw some atoms were just giving off heat, I guess, or just giving off light. So why is that? So of course, that's because they're radioactive. I don't see the MCQ. Can you post it again? If the charge is not mentioned, that means it is neutral. That means it's 0, so protons equal electrons. That's what it means, if the charge is not given. Okay. All right, so that was atomic structure. And now we are moving on to a very important second chapter that we have, which is purification techniques. Now, this is for all the branches. Okay, so all the branches are going to use this. Fajr, your question is strontium ion. So just look in the periodic table. Strontium ion would be 2+. So that is krypton. So krypton is the same as strontium ion. Okay. So for every element in the periodic table, yes, the charge is 0. So that means neutral atoms will always have protons equal to electrons. So yeah, that's true. Calculators are allowed in exam, yes. The charges on the periodic table are not mentioned because they're neutral. There's 0 charge. Yes, Rami.
So sir, everything we just did about atomic number, that's covering the second chapter, right? So we've covered the whole second chapter.
So in the second chapter, there are a couple of things that we haven't studied. For example,
yes,
the chemical formulas or the chemical equations or how to balance equations. But remember, as a rule, if you haven't studied anything in class, you should not be and will not be tested on that. Okay? That's unfair.
We should know
unfair.
like the about compounds and mixtures and everything, right?
Of course, you need to know how compounds are different from mixtures. That part is important. Yes. You also need to know that mixtures. So a couple of important points there are that mixtures have the same properties as what they're made of, but compounds have their unique properties. They don't have the properties of what they're made of. An example would be that hydrogen is explosive and oxygen burns, but water doesn't, right? It's neither explosive nor does it burn because water has its own properties. It's a compound. But you mix hydrogen and oxygen and you have a mixture that is explosive and it burns. So it's a very dangerous mixture, right?
Yes,
yeah.
Thank you.
Yeah, so mixtures have the properties that are similar to what they're made of, but compounds don't. Similarly, mixtures can be of any ratio. Like I can have half a hydrogen and half of oxygen, or I can have 3 times oxygen as hydrogen. That's up to me whenever I'm mixing them up. But if I want to get water, I can't be like, okay, today I want to have water that has the same hydrogen and oxygen, or maybe I want to mix things up a little bit and I want to have water that has double the oxygen as hydrogen. That won't be water. It won't be a compound, right? It'll be a mixture. Okay. Okay. Don't get too excited right now. We are not failing. Okay. We are making sure that the more you sweat in peace, the less you bleed in war. Okay. So yeah, right now, this is the time to actually prepare. And we will be prepared by the end of this class. No, you're not allowed to fail. I'm sorry, you're not allowed to fail. Okay, somebody else had a question.
Sir, I'm a little confused about the MCQ which you solved with Fajr. If you could please go over how we got that.
We'll do that at the end of the lesson, man, because I want to review purification techniques and I have another class starting in half an hour. So yeah, don't worry. All right, moving on. Purification techniques. Yeah, so I will take more questions, but let's just complete this now. All right, purification technique. There are some important definitions here as well. So for example, you need to know how compounds and mixtures differ from each other. So we talked about now. So compounds versus have their unique compounds have their unique properties, but mixtures have properties of what they're made of. Similarly, compounds have a fixed melting and boiling point. Mixtures have a range of melting and boiling point. Okay, Ali, you're right. I care about students, and students are like, my relation with you is completely different from whatever else is happening. Okay, yeah. All right. Wow, Alicia. Wow. Thank you, Alea. All right. So the second idea that you need to know about is there are 4 important techniques that you need to know about. And the examiner can ask you to draw the diagram, to read the diagram, to label the diagram. So that part's the diagram part. And then the second part that the examiner gives is they give you different mixtures and they ask you to predict what method you will use to separate. Okay, so there are again 2 different kinds of questions that they ask you this chapter. One is they ask you to predict what method you will use and how, and the other is they give you the method and they ask you to describe it or to draw a diagram or something like that. So I'm going to go over each one of those, and I'm going to obviously tell you how you will choose them. So again, the first kind of question, the methods. So there are 4 methods. So I'll quickly go over one of them, each one of them. The first method is, it has 4 steps. It is filtration. Okay, so filtration. But to do filtration, you need to dissolve. So the first step is dissolve in water, dissolve in ethanol, whatever they're dissolving. Dissolve, then filter, then crystallize. Okay, or if you don't crystallize, you dry. Or if you don't dry, you have to see what you're doing. So for example, if you want to get crystals, you do crystallization. If you want to get dry powder, you do obviously drying. Now, how does it go? I'll take an example. Let's say I have silver chloride. Again, wait a minute, I'll just write the full name. So silver chloride, and it's dissolved with silver nitrate. And the examiner says that this is solid and this is aqueous, or it is soluble. Okay, so one is soluble and the other is solid. That means it's insoluble. Okay, so soluble and insoluble. I don't know what the compound is. All I care about is that one is soluble and one is insoluble. And there's an example that I've been doing since grade 7. Sand and salt. Every definition that I gave to you in the class, you can fit that into the question. उसने जो भी बोला है ना, you just identify ये insoluble है, ये soluble है, ये salt and sand है. Okay, and there the thing becomes so much easier. तो हम क्या करेंगे? सबसे पहले we'll add water. And remember, you can write in points in the exam, but examiner will take them as a step-by-step process. They will read it as if it was a line. You can write it in decimals, oh sorry, not decimals, in points, and that's your choice, but examiner will take it to be a paragraph. Okay, so you can write in points if you want. If that's the case, I'm a little worried about your December exam syllabus. It's going to be huge. Okay, so yeah, it's okay. Wishing you all the best. All right, so how do you do this? Step 1, dissolve in water. Step 2, filter. Notice that I'm not writing, take a filter paper, fold it, put it in the funnel, nothing. I don't need any of that. Just filter. The examiner knows what filtration is. Okay, then here the question will tell you what they want. If they want the residue, then you will write that wash with cold water and dry in folds of filter paper. This is a technique that has been tried and tested, so you won't have to worry about it. If the examiner is saying, no, I don't want residue, I want crystals, then the method is slightly different. Here, you will not wash with cold water. Sorry. You will not wash with cold water here. What you will do instead is you will evaporate or heat to saturation point. Saturation point is also called point of crystallization. So you can either put saturation point or you can say point of crystallization. Don't write PT, just write the whole thing, okay? So point of crystallization or heat to saturation point. Then slowly cool. And that's how you get crystals. If you don't want crystals, if they want dry powder, then you heat to dryness. Or if you don't want to say dryness, you say heat to constant mass. And that's how you can easily get all of this correct. Dissolved water filter, that's a constant. It doesn't have to be water, it can be any solvent. So for example, if they say, oh, this thing is soluble in ethanol, you take ethanol, okay? And filter, and then residue and crystals. Okay, so I'm going to take a 1 minute break, just need to get some water. I'll be back soon. Okay, everybody. So let's start again. Yeah, so this was the first technique that if you have a soluble and an insoluble thing, you can separate it like that. Okay. Now, moving on. The second technique that you have, distillation is important if you have a liquid that you want to collect. All right. So if you want to collect liquid, then you do distillation. All right. Now, how do you do that? you basically make sure that the boiling points are different. Okay. So if the boiling points are different, then you can separate things that are obviously the liquids that you have there or not. So how do you get to that point? If you're starting as a gas, if you're at a gas, you cool them first. So for example, if you have air, you cool it down so that everything becomes a liquid or a solution. Okay. If you're already at a solution, you heat it. Okay. And everything boils when its boiling point comes. So I'm going to give you two diagrams for that. First diagram is that you have this boiling flask, there's the solution here, there's a condenser that's connected to this. So condenser goes something like this, looks like a weird jacket or something. And there's a thermometer here. This must be sealed. Remember, this must be sealed. And I will heat it. Over here, I should not seal this, and I will get the droplets out. One important point is that the diagram should show how the cold water or the cooling water comes in and goes out. That's one thing that must show. And of course, this must be sealed and this must be open. These are the three main points that you need to know about. All right. Moving on. The other diagram is where you have a fractional distillation. So this one works if you have a liquid and a solid. So you heat it, liquid boils, condenses, and you collect it. Okay, so if it was water, water will be collected over here, and whatever is left over will be obviously left over. If you have miscible liquids, and that's an important term, miscible liquids. Okay. Miscible liquids means liquids that dissolve together. They have similar densities, they mix together. People pay attention. Hadi, Laiba, pay attention. So miscible liquids, what they do is they basically, that's a good idea, Ali. We'll do that at the end of the class. So miscible liquids, they mix together. So to do that, again, what you have to do is you have to have fractional distillation. Okay. In fractional distillation, you use a fractionating column. There are two setups for this. One is the setup that we have in the lab, and one is the industrial setup. Okay. So yes, Zohar, you're right. Immiscible means liquids that don't mix together. It has to be liquids though. Okay. This class might go on for another half an hour because I have another class at 7:30. Okay, so here's how it goes. So you start with a flask. You connect this flask to the what you call fractionating column. So fractionating column has these beads in it. You don't need to like spend too much time on that. Just convey the idea that this is mixed together with something. And there's a condenser that's collected to this. And of course, this part is just like this one. There's it must be sealed. There must be a thermometer. And yeah, and of course, you'll collect things over here. So this is the setup that we have in the lab. A couple of important points. Liquid that you have should be heated. It will be collected over here. Okay. And the direction should be like this, the coolant. That's how it is. Now, how will you collect them? The liquid with lower boiling point is collected first. Okay, that's one. Temperature stays constant during boiling. So if a liquid is coming in, the temperature will remain constant. It will not change. Okay. Third step, if temperature changes, all of that liquid has been collected. Okay. So that's an important idea. In the MCQs, they might ask you, how will the student know that all of the liquid has been collected? The temperature will change. So for example, if a liquid boils at 78 and the temperature is 79, that means all of that liquid has been gone. It has been collected. Similarly, if the temperature stays at 78, that means that liquid is still coming up. Okay, so ethanol and water, that was a good example for this. So ethanol will boil at 78, water at 100. So that's how this will go. Now, sometimes they ask you a few questions related to this. For example, one question could be, they can ask you, identify the direction of cooling water. So it must go in from here, it must go out from here. Second point, they might ask you that where is the liquid with lowest boiling point? So the liquid with lowest boiling point is going to be collected here, or it's going to be over here at the top. Now, they might ask you, where's the liquid with the highest boiling point? So that won't be over here. That's the last one to come in. Okay? Do you get it? All right. Now, in the industrial setup, you have a similar thing. You have a large column, and this column might have a few taps. Okay. And it might be sometimes done like this. This is the industrial setup of this thing. The liquid comes from here. The mixture of liquids comes from here. And you can collect each of them from different types, like some from here, some from here. All of these tabs are for some different liquids. Now, in this one, if the examiner asks you, where's the liquid with the lowest boiling point? It's over here. It's at the top. And the liquid with the highest boiling point is at the bottom, over here. Okay. So liquid with lowest boiling point is at the top, and the one with highest boiling point. Hold on, I'm getting a call. All right, so as I was saying, the liquid with the lowest boiling point is collected at the top. So if the examiner asks you that, where's the liquid with the lowest boiling point? That will be at the top, so somewhere over here. Where's the liquid with the highest boiling point? So highest boiling point at the bottom, okay? So that will be over here. Okay, so examiner can ask you these things, that how do you find them and all. So just make sure that the liquid with the highest boiling point is at the top, the one with the lowest boiling point is at the bottom. Okay. All right, so that is the industrial setup for distillation. This is the other setup for distillation. Examiner can ask you to draw diagrams. They will be like, you may draw a diagram. Okay, that's how the question is phrased. I would suggest make sure that you draw a diagram. Okay, because if you're writing in paragraphs or if you're writing in decimal in these point form, a diagram, how they say a picture speaks 1,000 words, right? So it's always a good idea to draw a diagram, but do not spend too much time on the diagram. Okay, because the diagrams are supposed to be just guidelines, just a rough diagram. That's all it is. So you don't need to spend too much time on the diagram. If you don't draw a diagram, that's fine. Just make sure you have mentioned everything. Okay. Always draw a diagram that is labeled. Okay. So for example, in this one, I will label that this is a condenser. This is a fractionating column. This is a thermometer. Important things, not everything. You don't need to label like boiling flask or beaker or things like that. Just make sure the important things are mentioned. I won't be giving you any hints for the exam. We are here to review the syllabus, and that's what we'll do. You will be ready for the exam if you understand the syllabus. All right. The last one is this chromatography. Okay. Now, exam questions that deal with chromatography are of two kinds. In one, they give you the chromatogram. They have already done the chromatography. They ask you to read it. Okay, that's one kind of these questions. Okay, they will give you that and they'll be like, okay, can you read it? Okay, so for example, if you have a paper like this, okay, and of course, you need to be able to label it all. So for example, there's one line at the bottom. There's one line at the top. Let's say there are 5, or let's say there are 3 different things. So there's A, there's B, there's C, there's D. Okay, so A, B, C, D. And this is how the setup goes. So there's this. I'm just making it all up. Okay. All right, so a few questions that can be asked about this. First question. Which of A, B, C, or D has C in it? Okay. So that can be an MCQ question, that which of these has C in it? So what you do is you look for where C is, and if you draw a straight line, if it passes through something else, that has C in it. So you can see that this spot is the same. So D has C in it. Does D have B in it? Let's see. If I draw a straight line, pass through this, but if I draw another straight line, doesn't pass through anything in D. So D has this part, but not this part. So that means D does not have B in it. Okay. So one has C in it because C and D are on the same level. There's a spot in C that is in D as well. But there's a spot in B that's not in D. That clearly shows that D does not have B in it. Another question, why did A not move? Because you can see that A is right over here. It did not move. That means it is insoluble. That's why it didn't move. So things that are insoluble will not move. Okay. Similarly, they can ask you that which of these is pure. So we can say that C, because it has just given us one spot, that means it is pure. Okay. Similarly, they can say that what are these lines drawn with, or they can ask you to label these lines. So we'll label them. This one is called solvent front, and this one is called baseline. And we have to remember that we draw these with pencil because we don't want, basically pencil doesn't dissolve. So if this was not in pencil, it might dissolve itself. So the line would also just go away as dots or something. We don't want to do that. So we draw them with the pencil. Third point that they ask you about is RF value. RF value has a formula. It's in your book. You just need to take that formula. It's the distance traveled by solute divided by distance traveled by solvent. That's what the formula is. Now, how do you measure it? They can ask you to measure it in the exam. So to do that, you will obviously measure. So let's say they say, what is the RF value of C? So you will use a ruler and measure this distance. Sorry. So you'll measure this distance. Remember to start at the baseline. So you'll measure this distance and then you'll divide it by this distance. So in the exam, they can also give you like labels. They can be like, all right, so we have, so there was this MCQ in which they said, this is X, this is Y, this is W, and this is Z. What's the RF value? So now you know that W is starting at the bottom of the page, and that's not where you start. You start at the baseline. So the point is X distance away from the baseline, and the solvent front is Y distance away. So the RF value is going to be X over Y, and that's our answer. Okay. So that's one. They can give you the diagram just like they gave it over here. They gave it over here. They can give it over here. They can ask you to label it. They can ask you to identify how to use it. They can ask you to different questions about the diagram. Now, the second thing that they ask you is, ask you, how does something work? That's the second kind of question that examiner asks. They will be like, how would this process work? So for example, why do we dry the residue? We dry the residue because it's insoluble and we want to remove the water. Why doesn't it pass through the filter? Because it's too big for the filter paper. Okay, so small questions like that. Similarly, why do we heat crystals to saturation point? Because we don't want water of crystallization to go away. So small points, small questions that the examiner asks about each of these processes. Okay, distillation, they can ask you that how does this work? Or why does water come and not salt if this is water and salt? So why is that? That's because water has, as I said, the boiling point is lower, liquid that has a lower boiling point comes out first and the other doesn't. So for example, in the case of salt and water, the classic example that we took in the class, salt has a very high boiling point, water has a low boiling point. So water evaporates, is condensed, it's collected. But salt will not, because salt has a higher boiling point. So it will not be boiling and it will not be collected and all of that. Okay. Laiba, Rania, just please focus. Okay. Yeah. So that's the idea of how does distillation work. Similarly, how does this kind of distillation work? So the idea is that you have liquids with different boiling points, as I mentioned over here. They have boiling points should be different. So in this case, liquids have different boiling points. And because of that different boiling points, they are boiling at different temperatures. The liquid with lower boiling point is collected first. The liquid with higher boiling point is collected later. And that's how this works. This separates them based on their boiling point. First question is, why do we heat the solution to saturation point? We heat it to saturation point because that is when water crystallization is still there. Okay, that's why we do it. Khaja, Muller, and Faizan, please pay attention. Okay, I will be banishing you to waiting room otherwise. Okay, so we have this. The liquids that have different boiling points, they boil at their own temperatures, and you collect them based on that. If they have the same boiling point, then you will not be able to use this. Remember this. An examiner tests this in the MCQs, that two liquids have the same boiling point or they have really close boiling points. Can we use this definition, this method? No, of course not. We can't. Why not? Because this process depends on different boiling points. Otherwise, you won't be able to separate them. Okay. Why do we dry the residue? Because we need to make sure that all the water is gone. That's why. Similarly, over here, as I told you, why is the liquid with lower boiling point collected at the top? Because it has low boiling point, it evaporates first, it reaches the top first. That's why. Similarly, over here, they can ask you, why does this process work? Or how do you show that this process works? So to do that, you have to understand that chromatography depends on solubility. So if something is soluble, as you can see, A is not soluble. So A did not move at all. So let's say there's a question that, can you show how C is present in D? So you'll say, okay, C has an RF value that matches the RF value at another point in D, as you can see over here. So C has an RF value that is same as the RF value from a spot in D. This shows that C is present in there. Similarly, how can you show that something is a pure thing? Because it gives us only one spot. How can you show something is impure? Because it has, like, how do you show that some, for example, how would you show that B is a mixture? You will show that because through chromatography, B will have multiple spots. So if they say, okay, I know that B is impure and C is pure, can you show it on a diagram? Of course we can. You'll draw a diagram in which B has multiple spots, as you can see, and you will show that C has just one spot that shows it's pure. Similarly, can you use this to show that A is insoluble? Of course, we'll draw this whole diagram and we'll put just A there. It won't move at all. Can you show that C is present in D? Of course, we'll take the diagram, we'll draw it, and we'll just make sure that C is on the same level as some point in D. D can have multiple spots, but there must be a spot that's the same as this. Last important point for chromatography is that locating agent is used for colorless spots. Okay, so locating agent is used if you have colorless spots. That means if you have a spot that does not come up. So in the exam, they can give you that, okay, there was this past paper question that there are 2 amino acids and they are dissolved in water and we want to see them and they're colorless. So how we can do that? So the answer would be that you draw the diagram again, you draw the 2 amino acids. If you know what they are, you can also draw a pure thing. Like, remember in the class we did the example of paracetamol? So you can do that, okay, I have paracetamol on one side, I have the other thing on the other side, and you just draw that diagram. And then you label it. You need to label the baseline, you need to label the solvent front, you need to mention the locating agent for colorless spots, you need to mention the RF value. And these are the 4 important things of this method. That's all you need to mention. I think that's about it for this chapter. Okay, any questions that you might have for this chapter? I'll just answer those. Yes, you can unmute yourself. Hi.
Sir, could you please just repeat yourself? Because I missed the last point you said about mentioning these values. What value?
Yeah, so there are 4 things that you need to mention. You need to mention the solvent front and baseline. You need to label them. You need to obviously draw a diagram if they ask. You need to mention the formula of RF value, and you need to mention the locating agent being used for colorless liquids. Yes. Who's next? Yeah. Yes, ma'am.
Sir, I didn't have a specific question with this chapter. I had a question about the last chapter when you said in class you said we will have questions based on the lab experiments we did. Can you explain those a bit? What kind of questions will we get based on the lab experiments?
So the maximum they can ask you based on the lab experiment might be that they'll give you a diagram of a thermometer and they'll be like, okay, what's the reading on the thermometer? Or they can give you a beaker. They can ask you to read the value on the beaker. That's about it. You won't get any more than that. Okay. Also, that's more of an ATP question, and we start taking ATP questions later on. Not right now. Yes, Khatija?
Sir, my question was why would the temperature be constant when the state is changing from one state to another?
That's a very good question. In fact, that's a question that examiner usually asks. The reason temperature stays constant while you're boiling something or while you're melting something is because all the energy that you give is used to break the forces. So it's not used to raise the temperature, it's used to break the forces. And when you're heating something, the energy is used as kinetic energy of particle. It's used to speed them up. Okay, so those are the two main uses. Either it's used to speed them up or it's used to break the forces. If you speed them up, temperature changes. If you if you heat it up, temperature changes, kinetic energy changes. And if you change the state, then boiling point doesn't change, only the state changes. Okay, who's next? Yes.
Sir, I have a question regarding the revision sheet. Sir, in that revision sheet, there was a question: air is a mixture of gases such as nitrogen, oxygen, and argon. Describe and explain how each of these gases can be separated from polluted air. So I just want to confirm that first we would condense these gases and then we would carry out fractional distillation because these gases.
Because it's polluted air, there's just one extra point that you need to add, that you will filter it first.
I said that we use
because
what?
Polluted air, you will filter it first. Okay, and then you just use a filter paper. Not filter paper, you just use a filter basically.
So it's just one line that we have to add, and then we have to describe.
Yeah, just one line. That because it's polluted, that word tells you that you need to filter it. So it'll say we'll filter the air, and then obviously you can condense it and then boil them, and each of them will be collected based on their boiling points. The whole idea over here.
Yes, sir. If this sort of a question comes in the exam, how many marks would it carry?
I guess 4 or 3 marks.
So that this means that we have to explain the process of fractional distillation as well.
Yes, exactly. You have to mention that you cool them, then you slowly heat them. The one with lower boiling point is collected first, and while it is boiling, temperature stays constant, that kind of thing.
So are we expected to know their boiling points, or we just simply have to write?
No. If examiner wants, they can share that information with you that, okay, this one boils at this temperature, this one boils at this temperature. You will not be asked to remember or memorize that. Okay?
Yes, sir. Thank you.
All right.
Sir, when you were talking about crystallization, you mentioned a point that will evaporate it to constant mass. What did you mean by that?
What I mean by that is, so that was over here somewhere. So evaporate to constant mass means that you make sure all the water is gone. Okay? You just have to make sure that happens. Okay.
So, sir, I wanted to ask that, like you told us the question about locating agent. So, can you repeat the question? I didn't understand about locating agent, what the question would come.
About the locating agent, they'll either mention, as I mentioned the example of amino acids, they can say that there are 2 amino acids that are colorless and soluble in water. How can you identify them? So you can simply do the chromatography, the whole process. As I've shown over here, you draw the diagram, you label these, you use the RF value, and then you mention that locating agent can be used to identify colorless spots. So because it's colorless, you can use locating agent. Okay. Yes.
Sir, as Parisa said, ask you a question about gases. How can gases, but gases cannot be filtered?
You can. We use air purifiers, don't we? Similarly, we use all the ACs that we have in our houses. They all have filters in them. Cars have air filters in them. So gases can be filtered.
Okay,
the dust
sir.
particles will be stopped.
Okay, sir.
Yeah.
Sir, I had a question. In one of the worksheets that we did in class, it said that basically give us with melting and boiling points, and then you said which substance has particles in a disorderly environment at room temperature. So how do we solve that question?
Yeah. So there's only one state that has particles in an order. That's solid, right? Okay. Alicia, that's not a good way to say. If it is disorderly, that means it's either a liquid or a gas. Yes, Abrish?
Sir, I think हमारे September test में एक table आया था जहाँ पे हमें density predict करनी थी, वो समझ नहीं आया, तो समझा देंगे?
Remember, September test में जो questions, of course, you're not going to get the similar question in October, of course, because we have already tested you on that. As far as the table goes, you just need to identify that if you have a trend, you follow the trend. If you don't have a trend, you just say that we can't find that. So I'll give an example. For example, if there is a table like this, 3, 7, 9, and there's a gap, and there's a 50. So if you have something like this, then what can you do? Because you can see that the values are all increasing, there's a trend. Then you can see that this is between two values. You take the average, you add 9 and 15, you divide it by 2. So 24/2, you write 12 here. Okay?
Yeah, thank
you. But if they give you something like this, and they ask you to predict this, you can't, because there's no clear trend here. It's increasing, then it's decreasing. You'll just say that we can't figure this out. Okay? It cannot be predicted because there's no clear trend. That's what you say. Similarly, if they give you a question like this, and there's a gap here, so you identify what the gap is. So this is increasing by 4, by 2, by 2, or 3. So you can just put a different value here that you can clearly see that these are all increasing. So just pick a value that is in the same range. Like you could put 14 here, or 15 here, or 16 here, but only one of them, not all of them. Okay. All right. So I have to go for my A-levels class. So thank you so much.